All right, so in today's discussion, I want to walk with you on how we create document features and how this is actually part about the text feature engineering component that allows us to be able to conduct certain levels of text analytics. So inside our LMS, there should be a TDM example, and it will have some information regarding document feature modeling. And I want to walk through this so you can see the calculation. So the first thing, let's say that we have these three specific documents, and let's say that we wanted to give them a little bit of normalization, right? So what I'm going to do is I'm actually going to do this. I'm going to apply an Excel function. I'll call it lower, and I will apply it on B4. And now I can see what each of those documents might look like. Now, let's say that that is as far as I want to go. Let's say that I might want to remove some punctuation. So as an example, I might remove all the dots after Mr. For Professor Plum's green plant. I might just make it Professor Plum green plant, and et cetera, et cetera. Okay, so let's just assume that I do that level of cleaning. All right, now that I've made do that level of cleaning, let's go ahead and start writing each of the terms, or we're going to more or less tokenize each of these documents. So the first document has the term Professor Plum has a green plant in his study. All right. The next document has Miss Scarlett watered. Professor is already in there. I mentioned I would remove the apostrophe S. That's already in our list. Green is already there, as well as plant. All right. So the last document, really, if you look, the only word that is different is the word Mr. Mr. Green has a green plant, and all those pieces are already included. All right. So now let's go ahead and count how many times each word exists in each document. Well, since we did the first one, we know that all of these words are in document one at least one time. For the next one, we have to look at it like this. We have Miss Scarlett watered, doesn't have Mr. Professor Plum, and then green plant. All right. And then next, we're going to look at document 3. So document 3 has Mr., which is this item here. Has Professor, no. Plum, no. Has, okay, it has once, once, and green. But green actually occurs twice, and then plant is once. And then in his study, Miss, no, okay, all that. So now that we have all of these in place, let's go ahead and add up how many times each term occurs in the corpus. So this is going to equal to the sum of these 3 cells. And then we're going to go ahead and repeat that all the way to the bottom. And we can see that we have some words like green and plant that occur most frequently. Also, we know that we can count how many words are in each particular document by doing an equal to sum and just summing the values in all of these cells. And then we could copy that formula all the way from left to right. All right. And I'm just going to ignore all the errors because I don't know why it's giving me all that. So now we have the sum of the words that are in each document, and then the sum of total words in the entire corpus, and the number of occurrences a word is in the entire, in the entire corpus. What I'm going to do to make things simple, I am going to sort these words based on their frequency. So I just selected, starting with cell F12, going all the way to B24. I selected those cells. I'm going to go to data, and I'm just going to select Z to A. And what will happen is it'll sort everything for me, and I should get basically this appearance on everything. And all the math remains the same, but this tells me that green, plant, and all of these words occur most frequently in the document. Okay, so in order to conduct this right here, by the way, would be our basic bag of words term document matrix. So when we're looking at bag of words approaches, that's our basic bag of words approach. So one of the things that that we can do is start to normalize each term based on how it occurs in each of the documents. So for example, the word green occurs into this document once, but it is one word out of 9. So we can put a formula here that basically says I'm going to equal the count of that word and divide it by the sum of words in that particular document. So I will basically look at cell C26, and I am going to actually freeze it based on the row, so C26, and I am going to copy that formula from top to bottom. So I'm going to paste the formula. And then I am going to do the same thing here. I'm going to copy this, and I am going to paste it here. So now what we get is a normalized term frequency by document. So what this tells us is that how the weighting of each document or each word is in relationship to the document. So we can see that this word, which is green, has the highest weight per document. But this is only term frequency of the document. It doesn't take into account how things are in relationship to the entire corpus. So that's when we start to calculate an inverse document frequency. So first, what we need to do is we need to count how many times a word occurs in a document within the corpus. So what we're going to say is this is equal to count if, and we're going to select this range here, which is C12 all the way to E12, right? And we're going to count that if any of those are greater than 0. Oh, by the way, I forgot I have to put a little ampersand here so that way Excel will know that I'm trying to concatenate those items. So basically this first word occurs in 3 documents. So I'll copy all of this down, and you can see that really the only difference here is that this first word green occurs 4 times in the corpus, but it only occurs in 3 documents. And that is basically the document frequency of a word. Now, how many documents do we have? Well, this is actually equal to the count of these particular cells right here, these cells. Actually, I put count A. Hold on a second. Let me undo this. This is equal to count, and it's of these cells. And I'm going to create that as an absolute reference because that will not change. So there are 3 documents. So now the inverse document frequency is actually going to be the natural log of several of these items. So let me kind of share with you. It is going to be equal to the natural log of 1 plus the number of documents. I'm sorry, not the number of documents. The number of documents divided by 1 plus the number of times a document appears, a term appears in documents. All right, so basically, we actually use the 1+ to get rid of any kind of zero values, and we use the natural log in order to help smooth out the inverse document frequency. And by the way, what I'm showing you will actually be represented in our sklearn output. There are less smoothed out options for this. So if you happen to see this in a textbook, or if you do a ChatGPT or AI request on any of these things, the formula might be a little bit different, but notice that it is the relationship between the number of times or the number of documents we have versus the number of times a word appears in a document. So this first item, oh, and I forgot one more component. And also, to eliminate any kind of non-zero, we actually add one more 1 to it. And this first item ends up becoming 1. Okay. And now I'm going to copy that formula and I'm going to paste it down to all of the others. So I will paste that formula. And now we can see that we get different inverse document frequencies for every term. And this is related, this IDF is related to the term. So this is kind of like saying that basically closer to 1 means that it occurs a lot into a lot of documents, and then it based on the number of documents that we have. All right. And then the higher the number it is, that means it occurs in less documents, and it also may only occur in it occurs only in 1 document is what it comes down to in our case, or the least number of documents. All right. So now we're going to do what's called a TFIDF calculation, right? And the raw calculation is nothing more than taking this value that we have in the n column and multiplying it what is currently in our term document matrix. So what I mean by that is I'm going to set this equal to what is currently in C12, and then I'm going to multiply it by this inverse document frequency value. And since I'm going to copy this formula over, I'm going to make sure that the column n stays absolute. Right? So now I get this value of 1. So I'm going to copy this from top to bottom and then from left to right. And what this does is this starts to tell us how we can weight a specific term in relationship to the document that it exists in, that is also in relationship to the corpus. So if you look here, these 3 words end up becoming really descriptive, right, of document 1. And if we look at these documents, we can see that in document 1, in his study, is really the most unique words relative to the rest of the corpus. Let's take a look at these 3 words here, which is Miss Scarlet Watered in document 2. And we can see that Miss Scarlet Watered in document 2 is really the most unique words that are in that particular document. Now, the one that kind of has a problem is green in document 3. It is the most descriptive word for that particular sentence, but green also exists in all of the others. So this could actually cause us problems in the later aspect of things. But for now, we can still say that that is a huge identifier for sentence or document number 3. All right, we want to calculate the TFIDF based on Euclidean normalization. And if you're not familiar with Euclidean distance, just think of it as Pythagorean theorem squared. And if that doesn't make sense, it's okay. I'm going to show you how to calculate it. The first thing that we need is we need to calculate the sum of squares for each of the TFIDFs for each document, which is going to be equal to the square root of the sum of squares of the entire column. Pretty easy, right? I'm going to take that and copy that left to right. So now I have the square root of the sum of squares. And what this does, it basically allows us to get a sum value that is non-negative. And now what I want to do is now calculate with this value the new normalized based on Euclidean distance, which is nothing more than equal to our raw TFIDF divided by that square root of sum of squares. And I want to make sure that stays in the same row, so I'll make sure the row stays absolute. All right, so I am going to copy that from top to bottom. And I do have some conditional formatting in this, so if you're following along with me, make sure that you copy things the way that I am currently doing this for this. So I'm going to actually copy, and then I am going to paste here, and then paste here. And that conditional formatting then comes along, right? And now we can see how everything breaks together. And this is kind of more of a normalized TF-IDF pattern. And you would probably see this in sklearn if you were to do the same exercise and then look at the TF-IDF there. So I think it's important for us to step through how TF-IDF is calculated. This over here, as I may mention in classroom lectures, is our bag of words term document matrix. And then as a result of today, this here will be our TF-IDF vectors. Now, there's other things that will come into our conversation, and I've put them in the columns in the far right. We might want to know the dot product between certain documents, what the Euclidean distance is, and by the way, they're all 1 now. But most importantly is going to be what is down here in the bottom right-hand corner, which is the cosine similarity. So we can see that what the cosine similarity score is between each of the documents. So I've included that in this spreadsheet, and they'll get discussed more through our class time or through other online lectures. So as always, if you have questions or you need me, please reach out. And until then, I'll talk to you later.